All right. Hi, everyone. Today we're going to be talking about ethics case 4 and 5, where ethics case 4 is examining the question of human exploitation of space. Who can mine the moon? Why or why not? So on this slide, you'll see a really beautiful rendering of the moon where different spectra are colored in different colors. So this is constructed from a series of 53 images taken through 3 spectral filters. It was generated from NASA. Now I can tell you about the composition of the moon and why we would possibly be interested in mining it. So on the moon, there is oxygen, water, hydrogen, metals of different assortment, rare earth elements, helium-3, carbon, and nitrogen. Of these, elemental oxygen content in the regolith, which is this like silty material, this rock dust, is estimated at 45% by weight. Oxygen is often found in iron-rich lunar minerals and glasses as iron oxide. We also care about the water that is on the surface of the moon. Water ice is present primarily at the poles, particularly at the South Pole region. The extent to which any or all of these permanently shadowed areas contain water ice and other volatiles is not currently known. In fact, that is an active mission that NASA is soliciting for, to send rovers to these areas of interest to quantify the amount of water ice. Other things are hydrogen. Hydrogen is implanted onto the regolith from solar winds. Of the metals, iron is abundant in all mare basalts, but is mostly locked into silicate materials and into the oxide mineral ilmenite in the lowlands. Titanium can be alloyed with iron, aluminum, vanadium, among other elements, to produce strong, lightweight alloys for aerospace. And then aluminum is present in a mineral called anorthite, which is used in a lot of spacecraft structures. To speak to rare earth metals, NASA views the mining of rare earth minerals as a viable lunar resource because they exhibit a wide range of industrially important optical, electrical, magnetic, and catalytic properties. Another thing that the moon is known for is helium-3. In 1986, people proposed to exploit the lunar regolith and use the helium-3 for nuclear fusion, with a U. But of these people who have proposed, none of them have yet provided electricity commercially. And then finally, to wrap it all up, developing a lunar economy will require a significant amount of infrastructure on the lunar surface, which will rely heavily on in situ resource utilization technologies to develop. So we want to develop technologies that can harvest these different resources that we deem useful for either bringing back to Earth or expanding further out into our solar system. Okay, so I found a piece of legislation from 1979 that was specific to the moon. And the way that this is navigated, so we read the Outer Space Treaty for one of our previous readings. So I've abbreviated Outer Space Treaty, Article, in this case, 3, to show redundancy in something that we've already seen. For the 1979 Moon Treaty, the redundant parts that have been reiterated from the Outer Space Treaty are using space for peaceful purposes, the ban on weapons, the promotion of global interest and cooperation, and parts of transparency are redundant from the Outer Space Treaty, but what's new, I thought, was the statement that a state shall promptly inform the other state of timing of and plans for its own operations. and also that state parties shall promptly inform of any phenomena they discover in outer space, which could endanger human life or health, as well as any indication of organic life. Some other redundant policy is science investigation. You read this from the Artemis Accords, where we want to publish scientific data, make it distributable to other people who are interested in making scientific discoveries. Some other things, what was the most prominent about this 1979 Moon Treaty is this statement that the moon and its natural resources are the common heritage of mankind. There's almost this language of ownership, of entitlement. The moon is not subject to national appropriation by any claim of sovereignty. So it is not entitled to a specific country, but it is entitled, it seems, to all of mankind or humankind. And then the third part of this article is neither the surface nor the subsurface of the moon shall become property of any state, international, intergovernmental, or non-governmental organization, ... So this Moon Treaty, the way that it was written and the way that you read it, was only ratified by very few countries. In the backdrop of this slide, the red countries are those that did not ratify this Moon Treaty, and the green ones are the ones that did. So you notice that the major players in space did not agree to these articles. So the legal considerations, if we look back at the Outer Space Treaty and at the Artemis Accords, which is what, 50 years? Yeah, 50 years after the Outer Space Treaty, we can see themes that no nation claims ownership of any part of the moon's surface. But we also see some controversial topics that mining of space resources is unclear and controversial. The difference between the Outer Space Treaty and the Artemis Accords, where the Artemis Accords is supposed to be some updated referendum on the usage of space resources. The Outer Space Treaty had imprecise guidelines, but it was more widely adopted. So the backdrop here are the countries that ratified the articles within the Outer Space Treaty. But come to present day 2020, granted it was at the end of 2020 that the Artemis Accords were proposed, only a handful of countries have ratified the terms. So just to review, when the Artemis Accords talk about space resources, they say, the signatories note that the utilization of space resources can benefit humankind by providing critical support for safe and sustainable operations. Here's a big one. The signatories emphasize that the extraction and utilization of space resources should be executed in a manner that complies with the Outer Space Treaty in support of safe and sustainable space activities. And the signatories shall commit to informing the Secretary General of the United Nations. So there are more explicit guidelines, but as of yet, there's very little buy-in. So that's something maybe we should consider in today's discussion. Okay, I thought another piece of interesting legislation was a recent, I think it was an act. It was a legislative act passed by Congress that dictated the role of companies in exploration and utilization. So here's an excerpt where when Congress was talking about commercial exploration and commercial recovery, they wanted to state that the president shall facilitate commercial exploration for and commercial recovery of space resources by United States citizens. Another role should be that the president shall discourage government barriers to the development of these technologies. And finally, to promote the right of United States citizens to engage in commercial exploration. When it comes to asteroid resource and space resource rights, here is a piece of language that might go against some of the global policy, stating that a United States citizen shall be entitled to any asteroid resource or space resource obtained. So I thought that this piece of language was interesting in that an individual seems to be entitled to space resources. As of right now, the space of companies includes companies like iSpace, Offworld, and DSI. I do have a picture of Planetary Resources that is now defunct, but this is still a really cool picture of one of their concepts. To describe iSpace, which is a Japanese company, iSpace has a mission to help companies access new business opportunities on the moon, including the extraction of water and mineral resources to spearhead a space-based economy. Planetary Resources, which is now defunct, was founded in 2009 with the goal of developing a robotic asteroid mining industry. Despite having high-profile founding investors, including Alphabet's Larry Page, Eric Schmidt, and Virgin Group founder Richard Branson, Planetary ran into financial trouble in 2018 and was gone by 2020. Deep Space Industries, which is DSI, is also defunct, but was another early mover that intended to explore, examine, sample, and harvest minerals from asteroids. DSI was acquired by Bradford Space in 2019. Another company is called Offworld. It's an AI company building universal industrial robots to do the heavy lifting, including mining, on Earth, the Moon, asteroids, and Mars. And then there are some others called the Asteroid Mining Corporation, which is in the UK. And there is a company, or I think Luxembourg as a nation state is also developing a space mining framework. Okay, so we've kind of touched upon this in a different case study that I want to really delve into today. There is this concept called rights of nature, where we recognize that an ecosystem has the right to exist, flourish, regenerate its vital cycles, and naturally evolve without human-caused disruption. The goal of conferring rights to nature is to secure the highest level of environmental protection under which an ecosystem can thrive and whose rights are not violated. After a little digging, you can find that these different entities, these different natural entities, have rights of nature. In Ecuador, the Wanganui River, Ecuador, national forests, national spaces have rights of nature. The Wanganui River in New Zealand, the Rio Atrato in Colombia, and the Ganga and Yamuna rivers in India. On a smaller scale in the United States, the Pittsburgh ban on shale gas drilling and fracking was motivated by these rights of nature. Lake Erie has rights of nature, and the Canadian Magpie River also has some rights. Here on the top right, you will see an artist's depiction of Pachamama, which is an Ecuadorian concept, kind of anthropomorphizing nature. And then here I wanted to extrapolate maybe the anthropomorphization of the moon. Here is an artist's depiction of a moon god and How differently might we treat it if we thought of nature as a separate entity that is evolving and has health? So yeah, a little food for thought. Okay, so the prompt today is, as space will be commercialized, property claims by governments, corporations, individuals, or all three, we will need to make an order to operate business ventures without interference from others. Just as patent provides an inventor with the protection needed to invest the time and money in the first place, a company may be less willing to invest hundreds of millions or billions of dollars to, say, build timeshare condos on the moon without having clear rights to that property. Notwithstanding the UN treaties related to outer space that preserve space as a commons, what would be a fair process for claiming property in space? Should we opt for a free-for-all? Should we have more of a systematic process? So yeah, I'm going to stop the recording and we will have a discussion.